Section 6.2, Substitution. Essential question. How do you determine what to substitute in a system of equations? So there are three different methods for solving a system of equations. So far you have learned graphing, and now you're going to learn substitution. So it's kind of like three different ways to get the same answer for something. You could graph it, you could use substitution, or you could use elimination, which you'll learn in the next lesson, and you'll get the same answer no matter which method you use. Alright, so use substitution to solve the system of equations. So when you see two equations, you're going to look for the variable that's all by itself. So a variable all by itself on one side in this system is this y right here. This y is alone, but we have the 3x next to it, so we don't want that. So what I want you to do is circle what y equals. So 2x plus 1. Now let's say hypothetically, is x plus 1, let's say y equals 5. Where would you put 5 into the bottom equation? Well, you take 5 and replace y with it. So it'd be 3x plus 5 equals negative 9. Now instead of 5, we have 2y equaling 2x plus 1. So that is what we're going to plug in for y. So we're going to write this bottom equation, this one right here, and when I get to y, I'm going to stop, and I'm going to write 2x plus 1 instead. So 3x plus, and then instead of y, I'm replacing that with the, maybe I'll even change colors here. So 2x plus 1 equals negative 9. So instead of this y right here, I wrote 2x plus 1. Now I'm going to solve this equation. One other thing to help you out, you know you did the step right where I wrote the 3x plus 2x plus 1 equals negative 9 correctly if you only have one variable. So we only have x's in our problem now. If we had x's and y's, that's your red flag that you did something wrong. So 3x and 2x make 5x. Minus 1 on both sides. Divide both sides by 5. And we have x equals negative 2. Now the thing is, we're not all done. What we're trying to figure out is where do these two lines intersect? What that negative 2 means is that they intersect at negative 2 something. So we have to figure out what y equals for our y coordinate. Now how we do that is we're going to take this negative 2 and plug it in for x in one of our equations. I think the easiest one to plug it into is our circle. So if I write y equals 2, and then instead of x, I'm going to write a negative 2. So I'm just plugging it in right here. Plus 1. So then if I solve that, 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. Now I have my y coordinate. Now I'm done. So these lines intersect at the solution, negative 2, negative 3. So that's what this means. If you took those two equations and graphed them, they would intersect at negative 2, negative 3. All right, let's try another one. So we have 2x plus y equals 16, and y equals x plus 4. So I'm going to look for the variable that's all by itself, and that's this y. So I'm going to circle what y equals. Y equals x plus 4. Since it's y equals, I'm going to plug that in to y. So I'm going to write that top equation, but when I get to y, I'm going to stop, and I'm going to replace it with x plus 4. So 2x plus, I'm going to stop. I'm not going to write that y. I'm going to write x plus 4 equals 60. Train tracks. Let's see if I did that first step right, where I wrote the equation. I only have one variable, I only have x's, so I know I did it right. 2x and x, or 1x, make 3x. Minus 4 on both sides. Divide both sides by 3. And x equals 4. So, my x coordinate for my answer is 4. So now I'm going to take that 4 and plug it into x into one of my original equations. Once again, I like to plug it into my circle because I think that's the easiest one to solve. So y equals, instead of this x, I'm going to put a 4 and then plus 4. So 4 plus 4 is 8. So if I graphed those two equations, they would intersect at the coordinate point 4, 8. All right. So look at my two equations and look for the variable that's all by itself. That's x this time. So x is equal to 4y minus 6. Since it's x equals, I'm replacing x with 4y minus 6. Now this is the first time I've had a variable out in front of my, or a number out in front of my variable. So I'm going to write that 3, and then instead of the x, I'm going to put 4y minus 6 in parentheses, because it's not just the 4y that the 3 is getting multiplied by, it's that whole thing. So then plus 5y equals negative 1. So what is in red is what got substituted in. Keep in mind this method is called substitution because you're substituting something from one equation into the other. So you're substituting 4y minus 6 in for x. Check and see if I only have one variable. I do. It is y, so that is a good thing. This time we're going to start by distributing. So 3 times 4y is 12y. 3 times negative 6 is negative 18. I have same side-like terms again, even though they're not right next to each other, that's okay. Positive 12y and positive 5y make 17y. Add 18 to both sides. So y equals 1. So 1, except this time it's y equals 1. So I can't put it in the x spot. I have to put it in the y spot. So I'm going to take 1 and plug it back into my circle for y. So x equals 4 times 1 minus 6. So x equals negative 2. So our solution is negative 2, 1. So once again, if you graph those two equations, they would intersect at the point negative 2, 1. All right, 5x plus 2y equals negative 1, and x equals 3y plus 10. So look for the variable all by itself and circle what it's equal to. So again, it's x, so we're going to plug it in for x. So we're going to replace x with 3y plus 10. Alright, so I'll start by checking to make sure I only have one variable. I do. Distribute. So 15y and 2y make 17y. Minus 50 on both sides. So I have 17y equals negative 51. And then negative 51 divided by 17 gives me negative 3. So negative 3 is my y value. And then my x value, plug negative 3 back into my circle, so x equals 3 times negative 3 plus 10. So x equals plus 10, which is, so these lines intersect at the ordered pair 1, negative 3. All right, last one. This time you'll notice that both equations say y equals. So I can circle either one. It doesn't matter which one I choose. I'll just pick the top one. Since it's y equals, we're going to plug it in for y. So we'll have 2x minus 4 equals, so we plug it in right here, 3x plus 1. I only have one variable, so I know I did it right. Let's get our variable on the same side. Oops, negative 4, negative 1, so negative 5. Now, I can take my negative 5 and plug it back into my circle. So y equals 2 times negative 5 minus 4. So y equals negative 10 minus 4, negative 14. So these lines intersect at negative 5, negative 14. Summary.